Hello and good afternoon. Checking in again. Today we're going to go through problem number 5 from the 2018 AP test, which looks like this guy right here. We've got a function that's a exponential function multiplied by a trig function, and they ask us to do a lot of stuff with it. So probably good to know how to do all of these elements. This is something you could definitely see on the 2020 test. So let's dive into it and take a look. So originally they say let f of x be the function e to the x cosine of x. Find the average rate of change of f on the interval from 0 to pi. So if we want to know what the average rate of change is, this is not the instantaneous rate of change. This is the average rate of change. So the average rate of change is just going to be f of pi minus f of 0 divided by pi minus 0. That is my average slope, because average rate of change means average slope. So we're going to take e to the pi multiplied by the cosine of pi minus e to the 0 cosine of 0 divided by pi. I'm going to box that answer and be done with it. That's all I needed to do. If I was going to simplify this more, I could. E to the pi is just e to the pi. Cosine of pi is -1, so I'd have negative e to the pi minus e to the 0 is 1. Cosine of, sorry, this should be 0, not theta. Cosine of 0 is going to be 1, so this is just 1 divided by pi. And I could also leave my answer this way. But this would be fine on the AP test. Second part, they say, what is the slope of the line tangent to the graph of f at x equals 3 pi over 2? So now they want the slope of the line at a specific point, which means that we're dealing with an instantaneous rate of change. So we're going to take f prime of 3 pi over 2. I would start off by just writing this, because that shows the grader that you know that you need to take the derivative of f. Now we're going to try to take the derivative of f. That's going to be a product rule. So we have the first multiplied by the derivative of the second, which is going to be negative sine of x, plus the second, which is cosine of x, multiplied by the derivative of the first, which is still e to the x. We are evaluating this at 3 pi over 2. So we're going to have negative sine of 3 pi over 2 times e to the 3 pi over 2 plus cosine of 3 pi over 2 times e to the 3 pi over 2. I will leave my answer like that because it is a free response question, which means that my algebraic steps or simplification are unnecessary. I'm going to call it done. Part C, find the absolute minimum value of f on the interval from 0 to 2 pi. Justify your answer. This is a non-calculator question. So if we want to find the absolute minimum, first of all, we're going to be interested in our boundaries. So we're going to check f of 0 and we're going to check f of 2 pi. We're also going to check our places where our derivative changes signs. Now our derivative was up here. F prime of x is equal to the negative sine of x times e to the x plus the cosine of x times e to the x. We could factor in e to the x out of that, so we had e to the x multiplied by negative sine of x plus cosine of x. And if we're interested in where that is equal to 0, so that we can find out where our sign changes are. E to the x is never going to equal 0, so really we're just interested in where 0 equals negative sine of x plus cosine of x, which means that we're interested in where sine of x is equal to cosine of x. And this happens at pi over 4, and it happens both at pi over 4 and down here in the unit circle at 5 pi over 4. Those are our critical values, and then the question becomes whether our slope is changing from negative to positive or positive to negative. If we're interested in a minimum happens when our slope goes from negative to positive. So if we make a little sign chart of our slope, we have pi over 4, we have 5 pi over 4. If we plugged in a number in between 0 and pi over 4, let's say pi over 6, we would end up with e to the pi over 6, which is positive, multiplied by cosine of pi over 6 minus sine of pi over 6. That's a bigger x value than it is a y value, so that would be a positive value. So we have a positive times a positive, which is a positive. If we were in between pi over 4 and 5 pi over 4, say at pi, e to the x for pi is going to be positive. Cosine of pi is negative 1. Minus sine of pi is 0. That's going to be negative, which means that we're negative in this space. And then after 5 pi over 4 at, say, 3 pi over 2, first value is still positive. And then cosine of 3 pi over 2 is 0. Minus sine pi over 2 is going to be negative 1, so that becomes a positive. So we're positive in this space. So the value that we're interested in checking is at 5 pi over 4. That's where our slope goes from negative to positive. So we would check f of 0, f of 2 pi, and f of 5 pi over 4 to see which one is the smallest. So we go back to plugging it into our original function. We have e to the 0, which is 1 times cosine of 0, which is going to be also 1. We have 2 pi, which is going to be e to the 2 pi multiplied by cosine of 2 pi, which is 1. This value is obviously bigger than this value. And if we try 5 pi fourths, we'd have e to the 5 pi over 4 multiplied by the cosine of 5 pi over 4. Now the cosine of 5 pi over 4, that's down here, that's a negative. That's the negative square root of 2 over 2. This is positive, this is positive, this is negative, which means that my absolute minimum in 0 to 2 pi, and they asked for the minimum value, so we want the y value, is equal to negative square root of 2 over 2 multiplied by e to the 5 pi over 4. And there we go. Now we move on to the last question. It says, let g be a differentiable function such that g of pi halves equals 0. The graph of g prime, the derivative of g, is shown below. Find the value of the limit as x approaches pi halves of f of x over g of x, or state that it does not exist. Justify your answer. So I'm guessing that this is going to be a L'Hopital's rule situation. If we plug in pi halves into g, we know that this is going to be 0. So we would have 0 here. If we plug in pi halves into this thing, we'd have e to the pi halves multiplied by 0, which is going to equal 0 over 0. That means that we can use L'Hopital's rule. So that means that we're going to take the derivative of the top divided by the derivative of the bottom. Now, g of pi halves, if we look at this thing, this is the graph of g prime right here. So we know that the derivative of pi halves is 2. The derivative value at pi halves is 2, rather. So this is the graph of the derivative. It doesn't matter that there's a corner here. We want the derivative value in this situation. So our denominator is going to be 2. And our numerator, I'm going to go back to what our definition of our derivative was, which was this thing. So we're going to have e to the pi halves times negative sine of pi halves plus the cosine of pi halves times e to the pi halves So simplifying this out, the sine of pi halves we know is going to be equal to 1. This is really negative 1 times e to the pi halves. Cosine of pi halves is 0, so this thing is 0. So we end up with negative e to the pi halves over 2. And that would be our value for this. Again, just to clarify, in this situation, this was a graph of g prime. Because this was a graph of g prime, we look at the value of g prime at pi halves. If I needed to take the second derivative, g double prime, I would say that g double prime did not exist at pi halves, but the value of g prime at pi halves is 2, which is why I can put 2 into the denominator here using L'Hopital's rule. And that's it. That's how I finished that problem off. Hopefully that was informative, and I hope everybody's having a great day. I will talk to you all again soon.